Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. We are in chapter 10, special probability distribution. In this video you will learn about Poisson distribution. We will learn on how to identify the Poisson distribution, identify the mean and variance, and also use the Poisson distribution to solve related problems. So what is actually Poisson distribution? The Poisson distribution is used to model situations where the random variable x is the number of occurrences of a particular event over a given period of time or space. There are three things to remember when it comes to Poisson distribution. The first one is the number of occurrences is a discrete random variable, or in other words, the number of occurrences is distinctive or takes one value after another. The second one is the occurrences are random, which is not biased. And the third one, the occurrences are independent. Okay, so here is the probability distribution function for Poisson distribution. As we can see, we use lambda as the parameter for this formula. The lambda here means the average number of occurrences of a particular event. And here's the probability of x greater equals to r, which means the total up the probability distribution function from x equals to r until n. This is a very important part because later we will learn how to find the Poisson probability by using the table, where the table only gives you the value of probability x greater equals to r. And now I'm going to show you how to use the Poisson probability tables. The values given here in the table are actually for the probability of x greater equals to r, where r has a Poisson distribution with mean lambda. For example, for this value here, 0.9957, this is the value of probability for x greater or equals to 2 with mean 7.6. For a Poisson distribution with lambda as its mean or average, the mean and the variance of the Poisson distribution is the lambda itself, where the standard deviation of the Poisson distribution is the square root of the lambda. Now let's look at two examples on how to solve problems by using the Poisson distribution. X is a random variable such that x with a Poisson of 5.7 as its average. By using the Poisson table, find a px equals to 3. Now we know that the lambda is 5.7 since the average is 5.7. So px equals to 3 will equals to, according to the formula, we can write it as e to the power of negative 5.7 multiplied with 5.7 to the power of 3 over 3 factorial. That will give us 0.1032. Or we can write it as px greater or equals to 3 minus px greater or equals to 4. By looking at the table, we know that the answer is 0.1032. For px greater or equals to 2 and less than 5. First, for this question, we rewrite this as px greater or equals to 2 less or equals to 4. For this question, we see that we don't have an equal sign here. It's easier if you change this or you rewrite this and put an equal sign. So less than 5 means it is less or equals to 4. Then we can write it as px greater equals to 2 minus px greater equals to 5. By referring to the table, we may find the value of the probability of these two, and then the answer will give us 0.3048. Okay, it's the same thing for C, px greater than 2 and less or equals to 5. So first we note that we don't have an equal sign here, then we change to 3 with an equal sign. Then we can change this to px greater equals to 3 minus px greater equals to 6. That will give us 0.4182. Of course, by referring to the table. And for the last one, so the same thing, we change it to px greater equals to 2 minus px greater equals to 6. By referring to the table, that will give us 0.4726. Now let's move to another example. The number of breakdowns in a particular machine occur at rate of 2.5 per month. Assuming that the number of breakdowns is following the Poisson distribution, find the probability that more than 3 breakdowns occur in a particular month. The question asks more than 3, so we write it as px greater than 3 with a lambda equals to 2.5. Now you see we don't have an equal sign here. First we change it to px greater equals to 4. And by looking at the table, we will get the answer 0.4562. So for B, find the probability that less than 10 breakdowns occur in a 3-month period. Now you see for A, we put lambda equals to 2.5. This 2.5 is actually per month. In B, the breakdowns occur in a 3-month period. So this means that we have to multiply 2.5 with 3. So the new lambda will equals to 7.5. We will use a new lambda for this one. And then we write px less than 10. Again, without an equal sign, change it to px less or equals to 9. We cannot find this probability on the table because the table will only give you the value of px greater or equals to something. So we change it to 1 minus px greater or equals to 10. By looking at the table, we will get 0.7764. And for the last question, find the probability that exactly 3 breakdowns occur in 2 months. Again, for this one, we have to change the lambda because the breakdowns occur in 2 months. So we take 2.5 multiply with 2, which is equals to 5. So we're going to use 5 as the new lambda. And then we write px equals to 3. You may use the formula to solve this, or you may refer to the table. So if you use the formula, we can write it as e to the power of negative 5 multiply with 5 to the power of 3 divided by 3 factorial, and we will get 0.1403. Well, that's all for Poisson distribution. I'll leave you with some exercises for you to try.